Hello everyone. Welcome to a new DMD Hangar team video tutorial. Today we will guide you step by step through the integration process of the multiplayer shooter system into any Unreal Engine 5 character. For this tutorial, we're going to start by using the Unreal Engine 5.7 third-person template as an example. Our goal is to integrate the MSS core so your project has a solid combat system from the very first minute. The first thing we need to do is configure our project. To do this, we must activate three fundamental plugins: Common UI to ensure interface compatibility with gamepads, Enhanced Input, essential for the input mapping our system uses, and finally, Animation Warping, which is required for the animation tools of the new Locomotion system that we will show you later on. The next step is crucial for the shooting system. We need to add custom collision channels. First, we create an object channel called Projectile and set it to block. Then we add a trace channel called Laser, also set to block. These channels will allow both physical bullets and laser traces to interact correctly with the environment and enemies. Now it's time to bring all the multiplayer shooter system content into our project. To do this, we must migrate the DMD folder directly into our project's content folder. It's a simple but vital step to maintain all material and blueprint references. Remember that both projects must be on the same Unreal Engine version, in this case 5.7. This ensures there are no compatibility errors or data loss during the migration process. Once the content is migrated, we need to configure the Common UI plugin so the interface displays and functions correctly. To do this, we'll go to the project settings and add the blueprints that are already integrated into the multiplayer shooter system. These files are essential for the system to automatically recognize whether we are using a keyboard or a gamepad. The shooting system uses several essential sockets, both for reloading with physical magazines and for accurately defining the weapon's position in the hand. To ensure everything fits perfectly, we are going to copy the sockets from the original MSS skeleton and paste them directly into our new character skeleton. Now, it's time to give our character its combat capabilities. We'll go into our character's blueprint, and in the Components panel, we'll add the BPC shooter system component. This component is the brain of the entire shooting system and will handle weapon management, inventory, and combat logic. Next, we are going to add the holster system to our character. To speed up the process, we'll directly copy the child actor holsters from the original shooting system character and paste them into our new blueprint. Remember that you can place them anywhere on the body depending on your design, but it is essential that they are always children of the character's mesh. This ensures they correctly follow the bone positions and that the system's physics work accurately during movement. For the shooting system to know exactly where to attach the holsters, we need to tell it which main mesh is responsible for carrying them. To do this, we select our mesh in the Components panel, and in the Tag section, we will add the tag root of our mesh. In this 5.7 version, the third-person template already comes with animation set up for four-way movement. To take full advantage of this with our shooting system, we're going to disable the Orient Rotation to Movement variable inside the movement component. Since the goal of the multiplayer shooter system is to create the foundation for a third-person shooter, we need to adjust the camera for accurate aiming. It is essential to position it so that the shooting trace doesn't accidentally intercept our own character's mesh. As an optional step, we can enable camera lag. This will give a much more professional and cinematic feel to the camera's behavior when the character moves or performs sharp turns. Additionally, we want a character to always face the direction the camera is looking so we can aim properly. To achieve this, we are going to enable the Use Controller Rotation UI variable in the character settings. We've reached the most important step, especially if you are using a character with a different size or bone hierarchy than the UE5 mannequin. We are going to retarget the necessary animation so the shooting system adapts perfectly to your model. To simplify the process and keep the project clean, we recommend saving these new animations in a folder that's easy to remember. Additionally, it is highly recommended to add a suffix to clearly differentiate them from the originals. This way, you'll always know which ones are the optimized versions for your character. With the new animations now retarget, we must update the animation list used by the weapons to avoid visual errors when interacting with them. To make this easier, we are going to take advantage of the multiplayer shooter system weapon hierarchy. There's no need to go weapon by weapon. We only need to update the montages in the BP master for each category. Thanks to inheritance, all the rifles or pistols you've created under that parent will automatically adopt the correct animations for your character. Of course, it will also be necessary to update the animations used for the MSS pose system, which is organized by weapon type. This system defines how the character holds each weapon both statically and dynamically. To do this, we are going to duplicate the original data asset and fill it with our new retarget animations. By creating a copy, we keep the system's original configuration intact while specifically adapting the poses to our new character structure. Once we have our new data asset ready and customized, the next step is to assign it to our character's BPC shooter system component. This way, the system will know exactly which animations and poses to play for this specific model. In this new version of the multiplayer shooter system, we can easily add upper body animations to any locomotion system using an overlay. To do this, we are going to add a linked anim graph inside our character's animation blueprint. Now we select the animation blueprint that we previously retarget. This will allow the multiplayer shooter system combat poses to integrate perfectly over the basic locomotion system already provided by this third-person template, maintaining fluid movement while the character wields the weapon. The system allows us to define exactly which pose the character will take when drawing a weapon, depending on their locomotion state. To enable this feature, we must add the BPI locomotion interface to our character. Once added, we will go into its function to choose the active movement state. Since this third-person template only has one basic movement mode, we will simply choose the one we like best so that the multiplayer shooter system animations synchronize correctly from the very start. We can't shoot if we don't have a weapon equipped, so the next step is to integrate the interaction system. To do this, we first add the BPI interaction interface to our character, which will allow us to detect and pick up objects from the environment. To save time, we are going to copy the interaction logic directly from the DMD master character. This block contains all the necessary input logic and, most importantly, the replication required for interaction to work correctly in multiplayer matches. When pasting the logic, it's normal for some compilation errors to appear. We simply need to clean up any unnecessary nodes and create the missing variables in our new character. Once compiled and error-free, our character will be ready to pick up its first weapon. Now that our character has the ability to interact, let's place the weapons on the map. Simply drag the weapon blueprints you want to test from the content browser directly into our scene. As you can see, the system is perfectly integrated and the animation overlay works well with this project's basic locomotion. However, there is a problem. This movement system always rotates oriented to the camera in a rigid way, without any rotation or smooth turning animations. To solve this, the multiplayer shooter system includes our new locomotion system. This component is designed to give our characters much more realistic movement, automatically managing rotations and displacements so they feel natural. We are going to add the BPC locomotion system component to our character. It's very important to keep in mind that, since both the shooting and locomotion systems have aiming logic, the order affects input priority. Ideally, the shooting system should be added after the locomotion one so everything works in harmony. Additionally, our locomotion system already provides all the necessary logic for the character to move correctly with both keyboard and gamepad. Therefore, we are going to remove all the old movement logic from the template to clean up our blueprint and avoid unnecessary conflicts. In case you are using a character with a different size or bone hierarchy than the UE5 mannequin, you will need to retarget the animations named unarmed. We will do this the same way we did before to ensure the base movement remains fluid. Some of the animations used for the aim offset, which ensures the head follows the camera's orientation, might need their master animation updated. To avoid going one by one, we are going to perform this update quickly for all of them at the same time. By defining the correct master animation for this new skeleton, the aim offset will calculate the angles accurately, eliminating any deformations in a character's posture. Just like the shooting system, the locomotion system also uses data assets to decide which animation to use at any given time. This means that if your character requires specific movements, you can modify these files without any issues. Now we're going to modify our character's animation blueprint so it stops using its basic movement system and starts using our locomotion system. This change is essential for the character to respond correctly to the new turning and displacement mechanics. It's possible that some compilation errors may appear in the locomotion animation blueprint we just created. This happens because, during the retargeting process, some nodes do not automatically update with the new references for our skeleton. To fix this, we need to go into the affected nodes and manually assign the correct animations for this new skeleton. Once we have reassigned the retarget versions, the errors will disappear, and the locomotion system will run completely smoothly. Unlike the basic template, this locomotion system does use several movement modes, so we must synchronize them with the shooting system poses. To achieve this, we are going to update our character's locomotion mode function. By linking the current state of the locomotion component with the shooting system, the upper body and leg animations will work in perfect harmony depending on the action we are performing. The shooting system allows for hip firing, so we need to notify the locomotion system whenever we are aiming or shooting. To ensure this communication is constant and fluid, we are going to copy the event tick from the original DMD project character. This code block contains the necessary logic to update aiming states every frame and ensure the body orientation is always correct during combat. Lastly, this template has a very high value in the braking deceleration falling variable, which interferes with our locomotion system's jump behavior. To make mid-air movement feel natural and fluid, we are going to reset this parameter to its default value. As you can see, we have now integrated both the shooting system and the locomotion system into a brand new character from scratch, and it's working flawlessly. We now have start/stop animations, turn in place, and aim offset for the head, significantly raising the project's visual quality. Additionally, weapon poses change dynamically depending on the locomotion mode, whether walking, running, sprinting, or crouching. The system also features an improved foot IK that ensures the feet are always correctly positioned on any surface of the map. Remember, you can join our Discord channel for more information. Thank you so much for your support, and we'll see you soon.